Eventually, chiplet architectures will outscale simple monolithic designs. Nvidia simply can't afford to not invest into chiplets. Currently, Nvidia is in a very comfortable spot, and until the latency problem for gaming isn't fully solved, monolithic chips can still compete well.
Is the chiplet revolution coming for Nvidia? Their graphics cards and AI accelerators dominate key markets today, but for how much longer? Rival AMD now chains together multiple chiplet dies in their GPUs and CPUs. Intel revealed its Ponte Vecchio GPU with nearly 50 chiplets inside. So will Nvidia be forced to move from their tried and true monolithic chips to stay competitive? Can they make this manufacturing shift to modular designs? And even if they do, could they lose their edge in the process? Should they defend their monolithic fortress, or will they be forced to modularize as well? Let's find out. Nvidia, founded in 1993 by Jensen Huang, Chris Malachowski, and Curtis Prim, has emerged as a global technology leader, revolutionizing the world of graphics processing units, GPUs, and artificial intelligence, AI. Over the past few decades, Nvidia has evolved from a graphics card manufacturer into a powerhouse in the fields of gaming, AI, machine learning, and high-performance computing. What are chiplets? First, what exactly are chiplets and why are they gaining so much attention? Chiplets are small, individual silicon dies, each containing a portion of what was traditionally an integrated monolithic processor. These chiplets can range from CPU and GPU compute tiles to specialized functions like RAM, I/O interconnects, and more. The key is how these modular dies are packaged together. Companies used advanced integration methods like high-density interconnects to combine chiplets on a common substrate or package. This provides several potential benefits compared to monolithic designs. Improved yields, since smaller dies have a lower chance of defects. The ability to mix and match different chiplets for specialized products. Scalability is achieved by incrementally adding more chiplets over time. Manufacturing flexibility. Some chiplets use bleeding-edge nodes while others leverage mature modes. Chiplets representing the continuing disaggregation and modularization in the semiconductor industry. By decomposing large monolithic chips into smaller building blocks, companies gain flexibility. This emerging chiplet architecture is a pivotal shift, one that promises improved performance, cost efficiency, and customization. But effectively leveraging chiplets also requires overcoming daunting integration challenges. Now let's discuss about Nvidia's GPU designs. Nvidia has achieved tremendous success by sticking with monolithic GPU designs. In this traditional model, all of the graphics and processing functionality is integrated together and manufactured on a single gigantic die. For example, their Ampere architecture GPUs for gaming and AI are produced on Samsung's 8nm process. Massive chips like the A100 and GA102 pack over 50 billion transistors onto a single piece of silicon, making them amongst the largest ever produced. Nvidia's upcoming Lovelace architecture will leverage TSMC's cutting-edge 5nm process to cram in even more transistors and push the envelope on performance. Sticking to monolithic GPU development has allowed Nvidia to fully leverage Moore's law, scaling and produce even more powerful graphics processors decade after decade. Integrating all functionality onto one die removes interconnect bottlenecks and facilitates very high bandwidth and low latency. This monolithic approach does have some downsides, however. The extremely large die sizes have lower manufacturing yields, increasing costs. Nvidia is also constrained to whatever foundry process can physically support such gigantic chips. The A100 already skirts the reticle limit for lithography equipment. In addition, a single die for everything limits Nvidia's flexibility. They cannot optimize different components by using the most advanced or cost-effective, efficient manufacturing processes. And functionally, the company must wait for architectural upgrades until the next GPU product cycle rolls around. Nevertheless, while not without challenges, Nvidia's laser focus on monolithic GPU development has fueled their dominance across graphics, HPC, and AI workloads for many generations. But this single die approach may face stiffer headwinds as the industry shifts to chiplets. So, well, yes, the competitors turn to chiplets. In contrast to Nvidia's commitment to monolithic GPUs, competitors like AMD and Intel are aggressively adopting modular chiplet architectures for both CPUs and GPUs. They are hoping to gain an edge by splitting large dies into smaller chiplets produced and packaged together. For example, AMD's EPYC server CPUs are built using a chiplet design with multiple smaller dies linked via infinity fabric. One chiplet contains up to 8 high-performance Zen 3 cores. Additional chiplets provide connectivity, I/O, security processors, and other functions. This modular construction allows AMD to optimize each component. The compute chiplets leverage TSMC's advanced 5nm process for maximum density and performance. Other chiplets use mature 12nm and 14nm nodes to reduce costs. AMD is applying the same principles to graphics. Their recent RDNA2 architecture pairs multiple small GPU compute chiplets with a central memory and I/O chiplet. The GPU chiplets are fabricated on TSMC's 7nm node, while the I/O die uses a cheaper 12nm process. Chiplet designs provide AMD flexibility. They can scale up or down the number of compute chiplets to target different power and performance points. AMD also benefits from chiplet reuse across product lines: GPU, CPU, APU, etc. Intel is also investing heavily in modular architecture as part of their IDM 2.0 strategy. They recently revealed Ponte Vecchio, their first data center-oriented GPU that will challenge Nvidia. Ponte Vecchio adopts a chiplet-based package design with over 40 individual dies contained in the package. Compute tiles are paired with RAM, interconnect fabrics, I/O, and other support chips. The GPU leverages multiple manufacturing nodes, combining Intel's 7nm computer with TSMC's N5 process for other components. By adopting chiplets, Intel gains flexibility to optimize cost and performance. Critically, they can also leverage their substantial packaging technology investments. Intel believes their advanced 3D packing know-how gives them a sustainable advantage over the competition. It's clear the chiplet model provides benefits, but also introduces serious integration challenges. AMD and Intel must architect high-speed interconnects traversing dies both horizontally and vertically. There are also significant power delivery demands for tiles spread across a large package. In summary, while Nvidia doubles down on monolithic GPUs, rivals AMD and Intel are racing forward with chiplet architectures for CPUs and GPUs. They are aiming to gain flexibility in manufacturing and design not possible with a single gigantic die. This transition won't be easy, but promises to reshape the semiconductor landscape. The chiplet revolution has arrived. Now, what are the advantages for Nvidia adopting chiplets? Nvidia is clearly taking notice. In a recent interview, CEO Jensen Huang stated that Nvidia's next-generation GPU architecture will combine chiplets and monolithic dies. But there are some challenges for transitioning to chiplets. However, transitioning to a chiplet architecture won't be easy, even for a company with Nvidia's vast resources and engineering talent. There are significant integration and packaging challenges, including high-speed interconnects between chiplets, power delivery, and hotspot management. There are significant integration and packaging challenges, including high-speed interconnects between chiplets, power delivery and hotspot management, latency considerations with signals traversing die, extensive changes to existing tools, and design methodologies. It can take years to correctly architect and prioritize modular designs compared to monolithic chips. Nvidia will also have to navigate inevitable first-generation issues as they validate new packaging methods. While a chiplet approach provides long-term benefits, expect Nvidia's shift to happen gradually over multiple generations. It's an exciting time in the world of advanced chip packaging and modular chiplet architectures. While Nvidia has dominated with their monolithic GPU approach, competitors are gaining ground using chiplets for both GPUs and CPUs. Adopting chiplets opens up advantages for Nvidia, but won't happen overnight. We likely won't see extensive chiplet adoption until future Nvidia architectures. Can Nvidia's current strategy maintain its dominance in this dynamic ecosystem, or will they need to adapt and innovate further to stay ahead? Thanks for joining us on this intriguing exploration of the tech landscape. We've delved deep into the topic of Nvidia's position in the chiplet market and the potential challenges it faces from competitors. Are the winds of change blowing, and is Nvidia's reign under threat? Let us know your thoughts in the comments below. If you found this video thought-provoking, don't forget to give it a thumbs up and hit that subscribe button to stay tuned for more captivating discussions. Until next time, keep questioning, keep learning,